Now it is my great pleasure to introduce Dr. Sergei Slussarenko. Dr. Sergei is currently the Associate Professor of the Belarusian State Agrarian Technical University, Belorussia, and he is also a member of the Italian Liquid Crystal Society. He studied at the Faculty of Physics of Belarusian State University and Kharkiv National University. After graduating in 1977, he worked at the Faculty of Radiophysics of KSU. From 1981, he worked at the Institute of Physics of the Academy of Sciences in Kiev. In 1990, he received the title of Candidate of Physical and Mathematical Sciences. Sergei is the author of numerous publications and international patents in the field of optical holography, laser physics, liquid crystal physics. He also worked by invitation at universities in Italy, USA, Spain, France, Germany, and Poland. His research interests include dynamic holography and photorefractive effects in semiconductors, polarization static holography and art holography, image analysis and programming, nonlinear and electro-optics of liquid crystals, and so on. He has more than 40 publications in leading journals and also possesses extensive experience in all computing experimental programming. Dr. Sergei was a finalist of 2013 Intel Contest Program of the Future. On behalf of all the members of RIOS, I welcome you, Professor, to this webinar. And I also welcome all the invited guests and participants to the webinar. A humble request to all the participants are requested to keep their microphones muted until the end of the webinar. After the talk, time will be given for interaction with the speaker. Also, all of you please take care not to present your screen in between, and link for generating e-certificates and providing feedback will be given at the end of the webinar. Now I kindly request Dr. Sergei Slussarenko to begin the presentation.
Thank you very much. I really proud for possibility to give a talk in such noble society. So, photorefractive effect in pure nematics. Here's some, again, presentation of myself. I'm associate professor of Department of Physics of Belarusian State University, my alma mater. So, let's few words only for refresh some for everybody. What is it photorefractive effect in my private opinion? So let's imagine that we have some yes, I'll will tell you about simplest photorefractive effect with diffusion space charge field formation. So let's imagine that we have a two beam, interferencing two beam is typical situation for grating formation in any light sensitive media. And let we have some crystal, it could be semiconductor or magnetoelectric crystal. And we illuminate this crystal by interferencing field. In the simplest way, it is sinusoidals. This illumination produced a generation of charge. Next is really in the part where we have more intensity will be generated more charge, photocharge. Next step in this process is a separation of charge due to diffusion. It's very simple process. After some time, we have a separated charge, plus and minus, in different place of our crystal or of our media. In this next step is the formation of space charge field. Between plus and minus will be generated electrical field, and in his order, this electrical field will produce a modulation of refractive index due to pockets or linear electro-optical effect. Modulation of refractive index produced a formation of grating. This grating normally exist for the moment where exist present over light or modulated interferencing light. In liquid crystal, such kind of effect was realized in several works about 2-3 decades ago by doping of liquid crystal, nematic liquid crystal, by some dye. And as a result was received effective grating formation. Moreover, in the second work with Professor Ku was reached extremely high nonlinear effect. In first case, in work in Rudenko-Sukhov was used nematic with rhodamine 6G. In second work, it was used nematics 5CB with methyl red. But liquid crystal is so funny media, my beloved media, which has a lot of possibility to be reoriented. Several years ago was created so-called Carr-Helfrich effect. What is it? Let's take some homeotropically aligned liquid crystal inside of cell. Application of DC field on this cell from the first look should only stabilize this picture, but not is so simple. Liquid crystal is media with extremely high anisotropy. This anisotropy is due to form factor or molecules. For example, birefringing of normal nematics reach up to 0.5. It's extremely high value. But also, this anisotropy produced very interesting things. When we apply electrical field along the along axis of molecules, along a director of the over cell, we could obtain, and applied electrical field, of course, we could see an interesting effect, which consists from formation of electrical field, new one electrical field, which is perpendicular to applied field, and consists from two component dependent of conductivity, anisotropic, and permittivity. These two components could reach a value much more biggest as applied field. Also, it's called Maxwell-Wagner polarization. This effect was found by Professor Helfrich, and from this time is called Carr-Helfrich effect. In case of original work, Helfrich observed growing of reorientation liquid crystal at initial reorientation was due to director fluctuation, which appeared due to some thermal process inside of our cell. Our idea was, let's use another one effect for produced initial reorientation. We proposed to use a so-called orientational nonlinearity, which was firstly proposed by Zldovich and Taberan in 35 years ago. What is main idea of orientational nonlinearity? If we put some electromagnetic field inside of liquid crystal cell, molecule of liquid crystal cell will be reoriented by this electrical field, and this value will be give us angle of orientation which present in these formulas. We decide to use this effect for try to write a hologram dynamic graphic inside of our cell. But firstly, we made some numeric simulation. What will be value of our transversal electrical field with application of few volt of DC external? You could see on this plot that value of this depending of angle of reorientation of our molecules. You could see if we will reach deviation of angle about 0.1 of degree, internal transversal field could reach about 5,000 volt per centimeter. It's enough big value in case with application about 1 volt of external field. Let's explain more detail. We call it light-induced Carr-Helfer effect. So experimentally, we have homeotropically aligned liquid crystal inside of cell. We illuminate this cell by light. It should be tilted because orientation nonlinearity extremely depend of angle of interaction. And this light produced small deviation of molecules of director from the initial state. Then we applied an external electrical field. This electrical field will be also modulated in place when we have a deviation of molecules. And moreover, this electrical field produced more deviation, more tilt of molecule of director of liquid crystal. And from the own turn, grow transversal electrical field. Experimental realization. We prepare a homeotropical cell filled by Merck 5CB nematic, pure nematics. Moreover, we specially make a choice of extremely pure nematics from Merck because avoid any additional charge or something what could be an impurity we could influence of our experimental idea. Homeotropic alignment will realize it by developing of surface by polysiloxane. This is some organic polymer, and at the cell we pointed a interference field from two beam of heli-cadmium laser. This is 0544 micrometer. It's deep blue. Total intensity was 4 or 5 milliwatt. It's really nothing. Next step, we apply an electrical field and obtain a self-diffraction, which is evidence of formation of grating inside of our cell. Intensity on first diffraction beam was presented on this plot. What I need to add that in the value of external voltage, more as 2.5 volt, we put our cell in dynamic scattering instability. So main Carr-Helfer effect is start to dominate in this voltage. So we find an area where the classical Carr-Helfrich effect does not work because the director fluctuation is low, but by orientation and nonlinearity, we provocate formation on grating. So we made a special classical measurement which is typical for any holographic formation. We measure a intensity of first diffracted beam depending of grating constant and find so biggest efficiency of cell diffraction is this period about 20 micron. Intensity of writing beam, intensity of diffraction beam present versus present in the next plot, we have a linear depending of intensity of diffracted beam from writing beam in the value of writing beam which was available for us. Next questions. Usually all the process in dynamic holography or dynamic grating is has a special questions if the answer of over media local or non-local. What is it? It means does a maximum orientation of our director, in our case, is in the same place where the maxima of intensity light or something other one. If we have a shift between intensity and media modulation, usually we have a exchange of energy between the beams. But in case of Raman-Natt diffraction, which is our case, is not so easy to control this effect. Orientation and nonlinearity is totally local. Angle between director and light polarization. Sorry, I make a small jump too fast. Sorry. Next step, we check how does a threshold intensity depend of angle between director or director and bisectrix of our beam. So angle between a beam and director. And was measured, and we find that really threshold grow with reduce of angle, and maximal with angle at 0, and minimal with interaction about 45-50 degree, which good correspond for over initial process as orientational nonlinearity. This result was published several years ago, but next idea was if our initial process extremely depend of polarization of light, why do not try a right so-called polarization grating? What is it polarization grating in our case? Let's organize a interference of two beams with crossed polarizing. In this case, we will have not any modulation of light, but we will have a modulation of polarization, and formation of grating will be depend of polarization. And really, it's work. We obtain a grating with typical diffraction of self-diffraction of polarization grating, where first diffracted beam has one polarization, next one has a perpendicular polarization. It's good support of our idea that orientation of non-linearity is starting process, and moreover give us an interesting possibility to have a grating without intensity light modulation. Diffraction efficiency versus intensity writing beam. Again, linear and practically similar to scalar grating. Hence, the same space frequency and diffraction efficiency. Next step, what I was told too early. Problem. What is position of grating respect to over interference field? In case of Raman-Nath diffraction, usually used a method so-called method of moving grating. For example, what is this over classical initial scheme? Beam splitter, 2 mirror, and crossed beams. But if we put to one of beam some phase modulator, it could be non-linear crystal with a plate electrical field. It could be piezoelectrical actuator of one of mirror which formate over grating, over field. It's up to you. It's different variant. And what we have. And if it's phase modulator, should be really some optical element which formate over necessary polarization. And finally, we put here a cell. Next step, now we check over grating in some not ordinary process. First, we write over holograms. It is constant light, constant intensity, a constant phase of each beam. It's format a self-diffraction. Next step, we change a phase of one of beam. So changing of this phase leads to movement of over interference field respect to writed holograms, writed grating. Because we have a dynamic grating which could dissipate very fast, so this reading phase moving time should be short. And this is experimental. 1, 2, and over one beam with possibility of shifting phase. What we have? We obtain a changing of intensity of beam after interaction. It show us, sorry, I go back a little bit. It show us that when we move grating move interference field respect over grating, we have fast reducing of intensity of one of beam. It means that initially was energy exchange with typical for non-local response of media. When we change a plate polarity of plate field, we have a process which work to another side. It means that we change a direction of energy exchange. It means that we change a position of grating respect interference field. It was really enough strange result. First of all, Carr-Helfrich effect is absolutely local. When we reorient some liquid crystal, apply the field reorientation should be in the same place, but not shifted respect to maximum flight intensity. And the same, no evidence why it should be changed where we change the polarity of light. But everything very strange usually has very simple nature. First of all, we don't be forget that formation of electrical field, DC electrical field, inside of media as liquid crystal or another one has a very specific, not very specific, has typical character. All field is formed near of one of two surface. It's so-called double charge layer formation. And really, formation of our grating in any case could be happened only near of one of two surfaces. But our interference field present in all volume of our cell. And when we make projection of our grating format in the one surface to one surface, we could see at this small shift difference between a position of grating and total interference field. So it could tell that answer of case of light-induced Carr effect is really local, but due to some experimental situation, we could observe an energy exchange between two beams, which is typical for non-local answer. It's practically all what I want to tell. Thank you for your attention.